You that have any question?
Right on the interval of like completion, does it matter whether you put the symbol before or after that? When I put it in, I had the right answer, and I just had to switch
You had to switch it.
it. I was.
Oh, okay. So we say that if let's say we have x greater than 3, right? Something like this. Let's say x greater than 3. Then what is our interval notation here? What is our interval? So when you put this one in the Cartesian number line, so this is 0, 1, 2, and 3 there. Yeah. So the values of x are greater than what? 3. So, and this one is not what? Not included. So it is of that, and it is going in that direction. So where do we start from when we're writing the interval notation? So we start from, actually we start from the left, and then the next one is to the right. So in this case, it will be 3 and then infinity. Okay? Are you okay now?
Yeah.
Yeah. So if it is x less than 3, yeah, so it should be in this direction, that way. So how are we going to write this? So we start from the left, so it will be negative, infinity, and then 3. Okay? Yeah. So that is how. Any other question? You're still good. Huh? Okay. So now let's come to compound inequality. So this is section 2.6. Compound inequalities. Compound inequalities. Do you guys like red, or I should not use it? Oh, okay. So what is a compound inequality? Section 2.6. So a compound inequality is made up of two inequalities connected by the word and or the word or. Two compound inequalities. The inequality is connected by and or the word or. For example, x, let's say plus 1 is greater than 3 and 2x minus 11 less than 7. So this is a compound inequality. Or x plus, let's say 3 greater than 5 or x minus 1 less than 9. This is also a compound inequality. Now let's start from and. The word and. So what happens if there is a word and? So what do we do? So for and, to solve the compound inequality with the word and, we look for all numbers that both make both inequalities true. Both inequalities that make both inequalities to be true. For example, example number 1. Solve 6x minus 3 less than 9 and 2x plus 9 greater or equals to 3. Graph the solution and write interval notation. Graph the solution. How should we solve this? So actually this is so last week on Wednesday, we were able to solve this, and that means we were able to make x the sum, right? Also what to do here, we also do the same thing. Now, and then we need to look for the values which for satisfy the two inequalities. So what is our first step? So step number 1. You need to solve each of the inequalities. So number 1, solve each of the inequalities. Solution. So we have 6x minus 3 less than 9 and 2x plus 9 greater or equals to 3. So let's solve each of the inequalities. So we need to make x the subject, right? So the first step is you take or you add plus 3 in both sides here. So what do you get? You get 6x less than what? Less than what? 12, right? So x is less than 2. x is less than 2. Then in this side, they put under and this side, you minus 9 here. So 2x greater or equals to 3 minus 9 is negative what? 6. So our x is greater or equals to what? Negative 3. X is greater or equals to 3. So that is our first step. So we have the values x less than 2 and x greater or equals to negative 3. X is greater. Okay, now, so we need to draw the number line for each one of them and then now combine. So the first one, we can put it like that. So this is 0, 1, 2, 3, negative 1, negative 2, negative 3. Then we can draw another one here. This is 0, 1, 2, 3, negative 1, negative 2, negative 3, and then 0, 1, 2, 3, negative 1, negative 2, 3. Okay, so the first one, x less than 2. X less than 2. So where does it go? This way, right? And then this direction. So this is x less than 2. The next one will be what? X greater or equals to minus 3. Where does it go? So negative 3. And then it is that way, right? Is it going that way? So it is going that way. So x is greater or equals to. So it is going that way. Sorry. I don't know why I did that. It should be here. Should be here. So should be like that. X greater or equals to negative 3. Now, you look at this. So we want to get the values which satisfies what? Both the what? The inequalities, okay? We should satisfy both the inequalities. So therefore, so what will satisfy both the inequalities? So the one which will satisfy both the inequalities will be this, which is going this way, and coming that way, right? Right? So what is our interval notation? Which will satisfy both the inequalities. So what will be our interval notation? So if we put, so it will be what? So looking at this, x is less than 3. This minus 3 is still less than what? Less than 2. And then when you come here, also x, this one is what? It can be 2. Can also be 2. So for it to satisfy both the inequality, then all those values should be within this. So therefore, our interval notation will be what? Right. So it will be bracket, negative 3, and what? 2, and then what? Parentheses. Then parentheses. It's very easy, right? Are we required, right? The three. No. Okay. You are not required to write it. I'll just try to show you. Sure. So you can just write it down.
On the example on the website, it says 3. It's not nice. On the notes online.
On the notes, maybe I made a mistake. Oh, yeah, it's a mistake. So you should include the -3 now. So it should be -3. It should be 3. And then another example. Another example. (4x minus 7 less than 9) and 5x plus 8 greater or equals to 3. So what is our first step? So we need to solve the values of what? X. Get the values of x. So here we take 7 to the other side. So 4x is less than what? 16, right? So our x is less than 4. Okay. Or x is less than 4. Then the next one here, 5x greater than, you take 8 to the other side, minus what? Minus 5. So our x is greater or equals to minus 1. Or x is greater or equals to minus 1. Then we can just draw one number. We can just draw one number. So 0, -1, -2, -3, 1, 2, 3, 4, 5, maybe. So our first is our first one is x less than what? 4. So what happens? Okay, this direction. So this is x less than what? Less than 4. And then this one is x greater or equals to minus 1. X greater or equals to minus 1. So what is our interval notation here? What is our interval notation? Right? Minus 1. And then what? 4.
Can we put that on forward? Put the bracket on the 5.
Just turn your number.
I need number 9.
Oh, you mean down?
On the-
Here is the right, the 5. X is less than 5 is what you have on the number line.
Okay. Should be here. I'm so tired. I had another class. Yeah. So this should be that way. Sorry about that. Yeah. Good. If we have another example here, 1/3 x minus 4 greater or equals to minus 2, and minus 2 x minus 3 greater or equals to 4. Greater or equals to 4. So we just follow the same step. now solve the values of x. So how can we solve that? How can we solve that? Okay, so here we can take -4 to the other side. So 1/3x greater or equals to what? 2. And what do you do here? We divide by what? -2, right?
Yep.
So when we divide by a negative, or we multiply by a negative, what happens to the inequality? You switch. So you don't change the inequality, but you just switch. So it will be, we multiply, it will divide by -2. So x minus 3, it will now be less or equals to minus what? -2. Less or equals to -2. Because we divide both sides by what? -2. Okay, the next step, multiply here by what? 3. So x is greater or equals to what? 6. And then here we take -3 to the other side. So x less or equals to what? 1. Now, come to the number line. So let's say 1, say 0 here, -1, -2, continue like that. So 1, 2, 3, 4, 5, 6. That way. Or maybe there is a 7. Okay. X greater or equals to 6. What happens? X greater or equals to 6. It does what? That way, right? It is going that way, right? So this is x greater or equals to 6. Then x less or equals to 1. X less or equals to 1. What happens? It is going what? X. Yes. So is there any solution? So that means there is no solution because it doesn't satisfy all the quantities. So there is, you can just write, there is no solution. There is no solution. I think in Newton, it will tell you, I think in Newton you'll use this. I think so. Yeah, if you find something which has no solution, then there is this value there, which is, we call this one empty. So that was, are we together? All right. Now let's come to solving so what happens when we have the OR? So what happens when we have the OR? So what happens when we have OR? Now, to solve the compound inequality with the word OR, we look for all numbers that satisfy either inequality. Either inequality. So we look for a number which can satisfy either the criteria. Well, any level inequality. We look for the one which satisfies any of them. So we will see how this can be written in terms of, or actually this one is satisfying either of the inequality. Okay, so an example. Example number one. Example number one. So 5 minus 3x less or equals to -1, or 8 plus 2x less than or equals to 5. So we just do just learn for the hand. So what is our solution here? So in this case, solve this and graph the solution and write the interval notation. Graph the solution and write the interval notation. So how should we solve this? So we have 5 minus 3x less or equals to -1, or 8 plus 2x less or equals to 5. So we need to make x the subject. So we need to take 5 to the other side. So minus 3x less or equals to -1. Sorry, -1. -5. So here it will be, we take 8 to the other side, 2x. So or 2x less or equals to 5 minus 8. So we get here minus 3x less or equals to -1? -6. Or 2x less or equals to minus, is it -3? -3. Then, what happens to the first one there? You divide by -3. What happens to the, you switch. So x is greater or equals to what? 2. Or here, x is less or equals to -3 over -3 over 2. 2.
Is that considered a fraction then?
Yeah, that's just a fraction. So -3 over 2 is like 1.1. 1.5. Now represent this one in a graph. So you just draw one, or you can draw the 3 of them. So you can say 0, 1, 2, 3 there. 1, 2, 3, maybe 4. Okay, so x greater or equals to 2. X greater or equals to 2. Where will it be? Which direction? That left. So it will go to the right. So this is like that. So this is x greater or equals to 2. Then x less or equals to -3 all over 2. So This is -1. Let's say 1.5 is here, right? So this is -3 all over 2. So where does it go? To the what? To the left. So this is x left. That's all equals -3 all over 2. So what is our interval notation? Is it satisfying either? Yeah. So if you take any value here, yeah, it is satisfying one. Right? Yeah. So it is satisfying. If you pick any value here, it is satisfying this one. Okay. So it is satisfying either. So therefore, how should we write our interval notation? So here, this one is going to what? Negative what? Infinity. So here it will be negative infinity, and then -3 over 2 brackets, right? And then this one is going to infinity. So this is 2, and then infinity. So since this one is satisfying either, then this is connected. So we connect this one by that. So we connect. So it's either satisfying this one or satisfying the other. So basically, this one is now the interval notation. So this is the interval notation. So actually, this, when you do the higher level maths, this is the union of the two. So it's connected by the union. Another example. Solve 2 all over 3x minus 4 less or equals to 3, or 1 over 4x plus 8 greater or equals to minus 1. Graph the solution and write in interpretation. So yes, just done. So we take this one to the other side. So 2 over 3x less or equals to what? 7. Or we multiply both sides by 4, x plus 8 greater or equals to minus 4. Then we multiply by what? 3 over what? 3 over 2 in both sides, right? So we multiply this one by 3 over 2, multiply this one by 3 over 2. Okay, so that and that will cancel. So our x is less or equals to 21 over what? 1 over 2. Or we take this one to the other side, x greater or equals to what? Minus what? Minus 12. Minus 12. So what happens? So we now draw the what? The number line. So we can start from 0. So we can put what? So you can say 5, 10, 15, and then what? Maybe 20 there. Negative, negative, negative. 5, 15, sorry, 10, 15, and 20 there. Okay. All right. So the first one is 21 over 2 is 21 over 2 is 10.5. Okay, so and this one is plus, so 10 point something. Let's say it's here. And where does it go? To the what? To the left. So it is going to the left. So x less or equals to 21 all over 2. X is greater or equals to negative 12. X is, so we can take negative 12 as here. And it is greater or equals to negative 12. So x is greater or equals to negative 12. So it is going in that direction. What is our interval notation? What is our interval? So basically this one is going to what? Infinity, right? And this one is also going to what? Infinity. So this can be satisfied by anywhere in the infinity, right? And this one is also satisfied anywhere in the what? So what is our interval notation? What is our interval notation? So our interval notation would be, so that will be our interval notation.
So if those weren't greater than or equal to, would that be empty? If both of those inequalities weren't greater than or equal to, they're just greater than and equal to, would that not be a solution? This is important.
Oh,
And they go together.
oh, this one is 4.
Yes.
So if it was not, it would be something else. But this one is 4.
So does board never have
So
no
this-
solution?
Look at this. This one is going to what?
Yep.
Infinity, right?
Mhm.
So anything between here and infinity is satisfied. It's good, right? And then also this one is going to where? Infinity. So anything, even including this one, is satisfied.
Correct.
Right.
So if that inequality symbol was not greater than or equal to, if it was just greater than, if it was just x is greater than negative 12, or x is less than negative or less than 21 over 2, and how they both go together, this, and since it's 4, is that still, I guess my question is, does 4 ever have a no solution?
Or, I'll give you that answer next time.
Okay.
Yeah, I don't want to say something. So basically, anything that is satisfying either, yeah, is the solution. Like this. But now, if this one was not, yeah, then we would have just have to this problem because it should satisfy both the inequalities. Are we clear on that? Yes. So this is going to, I'll give you that answer next time. Okay, so what else are we supposed to see today? Double inequalities. So double inequalities basically is just the and. So double inequalities. Double inequalities. So a double inequality is a compound inequality such that A less than X less than B. So that is a double inequality. So that is a double inequality. So this one is equivalent. It is equivalent to A less than X and X less than B. So it is always equivalent to that. So that is so when we write this one in term notation, what will be our interval notation? It will be parentheses there, parentheses. So if there was some equals sign here, then it would be what? And okay, so that is and. So that is and. For example, solve -4 less or equals to 3x -7 less than 8. So this one, graph the solution and write the solution in interval notation. Write the solution in interval notation. So how should we solve this? So what is the solution? So we have this double inequality 4x less or equals to 3x minus 7 less than 8. So how should we solve this? How should we? So we need to retain x. So that means we need to remove all these ones. So what you do in this side, you do it also in. So you need to remove this 7x. 7, sorry. So what do you do? So step number 1, remove this constant. So what do you do to 7? You add, right? So it will be minus. So what you add here, you also add in the right and the left. So plus 7 less or equals to 3x minus 7 plus 7 less than 8 plus what? Plus 7. So what you get is, this one is 3 less or equals to 3x less than 15. Less than 15. And then what next? You divide both sides by what? 3. So you divide by 3, divide by 3, divide by 3. So finally we get 1 less or equals to x less than what? Less than 5. So that is. So basically, this is equivalent to what? 1x less than what? 5. And there is what here? That is So it is satisfied. So the solution there should satisfy all the what? It should satisfy all the requirements. So we need to put this one in the number line. 0, 1, 2, 1. 2, 3, 4, 5, 6. So x less than 7. So we can start from this. X greater or equals to 1, right? So it is going which direction? So this direction, x greater or equals to 1. X less than 5. And it is what? It is that. So this is x less than 5. So what is our interval notation? So interval notation will be 1 and then what? 5. So that is our interval notation.
Pretty much just like solve the other hand.
Yes. Any question? So there are some exercise which I just put it there, so you can try them at home, and we still have time. We still have like 4 minutes. 4 minutes. Are you able to solve something here? Okay, from okay, let's try one. Yeah, which I have it here. So let's say we have something like 10 greater or equals to 3x minus 1 greater or equals to 0. So here you do what? You add both sides by 1. So we get 11 greater or equals to what? 3x greater or equals to 1, right? Then we divide, so 11 over 3 greater or equals to x greater or equals to 1 over 3. Then you represent that one in the what? Then you see whether you are going to get the value. Okay, before you leave, Alexander, Rebecca, how are you around? Holly, Zachary, it's not around. Brown,
Yes.
Clinton, Savannah, Nancy, Hunt, Cameron. Were you here last?
I wasn't here on Wednesday.
Oh, okay.
I was here one day. And not
Okay. Angeline,
Here.
Zoe, Maria, Abby, Liz. How do you pronounce this name? Miklis. Okay. Michael. This guy. Next. Lexia. Are you around? Are you the one? Oh, okay. Felicity. Caleb. Reed. Miranda, Snow, Philippa, Owen, Trent, Morgan, Colin, Canon, Mark, Smith. Okay. Does anyone have any issue with Newton? Did you, were you the one who wrote to me? Or you did it? So who did the homework late?
I did. On Monday.
On Monday? Okay, I will look into the 2.3. So all of you, if you got 100, then I'll give you 100. Yeah, but for the one for Wednesday and today, then you should complete them before the deadline. Okay. All right. So I'll see you on Monday.